This is a video tutorial for question 5, tutorial 5A. Question 5 asks us to differentiate certain expressions involving logarithms. The first one it wants us to differentiate is ln x take 1 cubed 1 minus x squared. Now, there's a few things that we need to know, but whenever we're differentiating logarithms, it's important that we use our laws of logarithms to simplify the expression rather than trying to differentiate something really ugly, needing to use the product and the chain rule. So, before I even differentiate, I'm going to use my laws of logarithms to simplify this. What I have to differentiate is ln x minus 1 cubed plus ln 1 minus x squared. Already this is looking better, but I can do better still. This is the same thing as differentiating 3 ln x minus 1 plus, this is the same as ln x plus 1 x minus 1. Sorry, not x minus 1, 1 minus x. Using difference of squares. So it's the same thing as differentiating 3 ln x minus 1 plus ln x plus 1 plus ln 1 minus x. So when I differentiate this, what do I get? I'm going to get 3 over x minus 1 plus 1 over x plus 1 plus 1 over 1 minus x, then multiplied by the derivative of the inside and the chain rule, I get a minus 1 here. So this is the same thing as 3 over x take 1 plus 1 over x plus 1 plus 1 over x minus 1, using the minus 1 to change the order in the denominator. You can see here that there's a lot of simplification that can happen. First of all, you've got 3, 1, same denominator, so this is 4 over x minus 1 plus 1 over x plus 1. Make them the same denominator, we get 4x plus 1 plus x minus 1 over x plus 1 x minus 1, and this is equal to 5x plus 3 over x squared minus 1. So that's our answer to part A. If we look at the next one, sorry, hold on here. If we look at 5B, we're asked to differentiate ln square root x minus a x plus b, assuming I suppose that a is some constant. Again, use our laws of logarithms. So this is actually asking us to differentiate ln x minus a over x plus a whole thing power half. That means that I can bring the power of half down. Ln x minus a over x plus a. Then I can use the laws of logarithms to split this up. So I get a half ln x minus a minus ln x plus a. Now we can differentiate. So we get a half. Differentiate ln x minus a, you get 1 over x minus a, minus differentiate ln x plus a, you get 1 over x plus a. So again, we can cross multiply here if we like, so still get a half out the front. This gives us x plus a minus x minus a over x plus a x minus a. So this gives us a half 2a over x squared minus a squared. So this gives us a over x squared minus a squared. So that is part B. So let's now take a look at part C. C. Here we have to differentiate ln of x. So this is actually, it looks a little tricky, but it's actually just an application of the chain rule. So we differentiate the outside. So the first one we're going to differentiate is this ln. So we're going to get 1 over, hold the inside constant, ln x times, now we differentiate the inside, we get 1 over x. So our answer is actually just 1 over x ln x. So not a lot to do there. The last one, 5D, we have to differentiate with a different base. So we're going to differentiate log base 2 of secant x plus tangent x. So there's a way to differentiate log base 2, I can't remember it, but what I do remember how to do is I do remember how to change base with my logarithms. So I know that log base 2 of x is the same thing as ln x over ln 2. So I'm just going to change this to something I do know how to differentiate. This is equal to differentiate ln secant x plus tangent x all over ln 2. And ln 2 is just a constant, so this is the same thing as 1 over ln 2 differentiate ln secant x plus tangent x. And now this is something I do know how to do. So again, we keep our 1 over ln 2 out the front, times, differentiate ln, I get 1 over secant x plus tangent x, multiply that by the derivative of secant x plus tangent x, so differentiate secant x, you get secant x tangent x, plus differentiate tangent x, you get secant squared x. Okay, so what can we do next? Actually, if you look at this, you see you've got secant as a common factor here. So this is 1 over ln 2. We'll factorize out one of the secant x's, and then we get, on the top line, secant x plus tangent x, and on the bottom line, we get secant x plus tangent x. You can see that these just cancel away, and you're just left with 1 over ln 2 secant x. It's possible as well that you aren't too happy with 1 over ln 2. It looks a little bit messy. This is the same thing as log base 2 of e, and we just multiply that to secant x. So that's the final answer. And that brings us to the end of question 5.